Have you ever watched a complex machine in a factory, performing an intricate series of actions, almost like a carefully choreographed dance? Each movement, each pause, and each transition happens at precisely the right moment to achieve a perfect outcome. What makes this level of precision possible? At its heart, sequential control programming is the method used to guide a machine or an industrial process through a predetermined series of steps or states. It ensures that operations occur in a specific, logical order, moving from one stage to the next only when certain conditions are met. This structured approach is fundamental to reliable and efficient automation in manufacturing and beyond. The core reason sequential control is so effective lies in its foundational principles, which mirror how we naturally break down and execute tasks. First, there is the principle of discrete steps. This means every complex operation is divided into smaller, individual, and clearly defined stages. Think of it like a recipe where each instruction is a single step, like mixing ingredients or baking. Second, the order of these steps is critical. They must occur in a precise, logical sequence. You cannot bake a cake before you mix the batter, and similarly, a robot cannot weld a component that has not yet been placed. Lastly, transitions between these steps are governed by conditions. A step will only complete, and the next one begin when specific criteria are satisfied. This could be a sensor detecting a part is in place, a timer expiring, or a motor reaching a certain speed. These conditions act as gates, ensuring the process integrity. Applying these principles in practice often involves using visual tools like state machines or sequence diagrams to map out the desired flow. A state machine, for example, clearly defines each possible condition or state of the system, along with the specific inputs or events that trigger transitions between these states. This allows engineers to design robust systems where every possible scenario is considered, and the machine always knows what to do next. It transitions from an idle state to a processing state to a completion state, all based on well-defined rules and triggers from the physical environment. One insider detail that underscores the power of this approach is its contribution to deterministic behavior. This means that given the same starting conditions, the sequence will always produce the same outcome every single time. This predictability is absolutely vital in industrial automation, where consistency and quality are paramount. Understanding these principles helps you design systems that are not only robust but also easy to troubleshoot, because the logic flow is transparent and repeatable. This also enables easier integration of advanced features, like error handling or conditional branching, where the sequence can adapt slightly based on detected anomalies, without breaking the overall process flow. Ultimately, mastering the key principles of sequential control programming empowers you to create highly dependable and efficient automated systems. By clearly defining steps, their order, and the conditions for progression, you build a solid foundation for automation that reduces errors, optimizes production, and drives consistent results in any industrial setting.
If you love exploring industrial tech, like, subscribe, and keep innovating with us.